So let's talk about a little bit of theory. It turns out that AX is congruent to B mod M has a solution X mod M um, if the greatest common, actually if and only if, so if and only if the greatest common divisor of A and M divides B, okay? And so if the GCD of A and M divides B, then this congruence, not only does it have solutions, but it has the greatest common divisor of A and M, whatever that number is, it has that many solutions. So if the greatest common divisor of A and M is 3, then there's 3 solutions for X mod M. If the greatest common divisor of A and M does not divide B, then there's no solutions. Okay, so just to put the final nail in here, I've really already said this in the line above, but just to reiterate, if the greatest common divisor of A and M does not divide B, then AX congruent to B mod M has no solutions. Okay. One other thing that I want to point out, and one other thing that'll be very useful for us, is particularly, so I'll call this a corollary. I'm not going to prove this fact, by the way. I don't want to get too bogged down with all the nitty-gritty details of number theory as much as I might want to. Actually, I love number theory, but we have different goals in this course than that. I want to really just talk about, so one corollary here, if A and M are relatively prime, in other words, if the greatest common divisor of A and M is 1, then the linear congruence AX is congruent to B mod M. First of all, that'll always have a solution because 1 divides every integer. And in particular, it has 1 solution. So if the greatest common divisor of A and M is 1, in other words, if A and M are relatively prime, then AX congruent to B mod M has a unique solution. Okay, so it has a unique solution, mod M. One last thing just to focus on, and I'm not going to spend too much time on this, but just one last thing to focus on. Let's go back to the original equation that we started this section with. 5x is congruent to 2 mod 7. I said that we had a solution x is congruent to 6 mod m. And the way I want to think about this, and this involves the way that we're formally thinking about how to solve these linear congruences and what it even means to work mod 7, there are infinitely many integers that are congruent to 6 mod, there should be a 7. But there's infinitely many integers congruent to 6 mod 7. You just take 6 and then you keep adding or subtracting multiples of 7 as much as you want. You can do that infinitely many times. There are infinitely many integers congruent to 6 mod 7. I'm thinking of all those integers as being the same because they all lie in the same equivalency class of 6 mod 7. So when I say that there's a unique solution, what I mean is that there's only one equivalency class that solves that solution, but there's infinitely many terms in each equivalency class. Okay, so the uniqueness refers to the number of equivalency classes, not the size of the equivalency class. Okay, so again, the number of integers congruent to 6 mod 7, there's infinitely many, but this is the one and only equivalency class that solves that solution. So it's in that sense that our solution has that our congruence has a unique solution.